All right, awesome. Let's continue here. In the question you just answered, hopefully you said that argon would have a smaller atomic radius than sodium because argon has more protons in the nucleus than sodium does, and they're all only out to the third energy level. So in this case, going across a row, it's actually charge that makes a bigger difference for the atomic radius. Okay? All right, so this picture is a summary of the trends for atomic radius on your periodic table. And at this point, I would take out your periodic table, get a pencil or a marker or something, and label it. So draw a big arrow going across the top. The atomic radius is smallest on the right-hand side when we go across a row, bigger over here. And when you go down a column, the atomic radius gets bigger because we're adding energy levels. Okay, and it's smaller on the top. All right, so I think I'll show you how to label up your periodic table here at the end. All right, so the summary again is that for atomic radius, within a column, it gets bigger as you go down because you're adding energy levels, shown here. And it gets smaller as you go to the right because you're adding more protons, which pull the electrons in closer. All right, so that's shown here. Okay, third energy level, pulled in tighter. All right, let's talk about ionization energy. Okay, this is just defined as the amount of energy that's needed to pull an electron away from an atom. So if you recall here for a second, when atoms lose an electron, they become an ion. Okay, in this case, they become a positively charged ion. So here's a picture of an atom with 3 energy levels. In the third energy level here, it's got 2 electrons, this one and this one. Okay, and if this electron were to get removed, it would be having only this one in the third energy level, and it would become an ion. And the amount of energy required to take that one away is called the ionization energy. Okay, and this again follows a very predictable pattern on the periodic table in the rows and the columns. So we'll talk about that. Okay, let's look at the columns. Okay, in a group, this is the same picture as before. Lithium, sodium, potassium. This is the key point from yesterday, one of them. Again, as you add energy levels, okay, there's a weaker attraction between the nucleus and the outer electrons. This is the same message as before. Okay, as we add more energy levels, these outer electrons have a weaker pull to the nucleus and to the protons. So then, of course, the question becomes, how does that impact ionization energy? Okay, so let's think about it for a second. Would it take more energy to remove an electron from lithium or potassium? Okay, another way to ask that question is to say which of those would have a greater ionization energy. Okay, so think about what you know about the force as you go down a column. Up here, the force is greater, holding those electrons in. For potassium, the force is less, holding those electrons in. So which of these two would require more energy to pull away an electron? Okay, so that is your next question in your Schoology quiz. Give it a thought and go ahead and answer that.